when we talk about web applications, what does those two mean. We're going to see again a little bit of IP addresses and something called DNS, which are sort of important components of the web. How do we create our first server, and what are the responsibilities that a server has to fulfill to be a good web server, as well as how is it that that server responds to the a request. So let's start revisiting what the internet is, and who would like to share what their definition of the internet is? Sorry, a little bit louder. Okay, somebody else? A bunch of computers connected, right? Sharing information between them, yeah. At the fundamental level, that is the internet. It's a bunch of computers all connected together. So the internet was invented around the 1960s, where a military-funded research project to share information between military bases started going on between 4 universities in the U.S. I don't remember exactly the ones that were involved, but in 1966, I think, they were able to transfer the first data packet from one university, from the computer sitting in one university, to the next one. And that was pretty cool, because before that, we had basically the telegraph. And yeah, the telephone was not around yet. Let's fact check that. The telephone. I think 1970s. No, so the telephone was there, but mixed. Well, and then 20 years later, the internet came, right? And the internet, yes, like people think about like the cloud as like this metaphysical thing, but no, it's actually really real. It's just computers connected, and there are cables that are going, that are crossing oceans to connect America to Europe, and America to the East, and America to Africa. So actually, I wanted to show you a small video about that, because I thought it was pretty cool.
We never stop hearing about how the internet's in the cloud, but really, it's in the ocean. About 300 undersea fiber optic cables are responsible for 99% of international data traffic. It's basically the same way we connect to each other in a single country, except underwater instead of underground. They transmit PewDiePie from Europe to America, and they connect stock traders in New York and London. And these cables, placed by private companies, are the backbone of the internet. But if you held one in your hand, it'd be no bigger than a soda can. There are just a few layers of protection from the water, including petroleum jelly. Yes, your internet is covered in Vaseline. They're vulnerable to earthquakes, at least, and it's naturally buried by sand, thanks to the ocean's current. And that process, it's both stunningly simple and mind-blowingly complex, is responsible for making the internet a truly global network. It's an idea that's audacious and crazy, and you think it has to be cutting edge, and it is. But it's also been going on for 157 years. Electric telegraphs have been around for a long, long time. Experiments in the early 1800s connected two ends of a garden using a clock that revealed letters. Then they moved on to two neighborhoods to help signal trains, and then multiple cities thanks to a network of railroad lines. Underwater submarine cables were one of the first ones was knocked out of commission by a fishing boat. By 1858, they reached around the Atlantic and across the world. That's how it's kind of gone since, laying cables that circle the Earth's oceans. The cables are unwound from the back of the ship, sink to the ocean floor, and the world is connected in speeds measured in milliseconds. There are ideas on the internet above to place their bets. That's because the best way to create the cloud is still by going under the sea.
So what do you guys think? Lewis?
What I recently found out also is that it's still more cost effective to ship information physically than it is to send it through the internet.
Thoughts? Michael?
SpaceX is going to start doing like the satellite internet.
Mm-hmm.
So maybe that'll
Yeah, those two him. Yeah. Land connected through this is in Denmark. And it's
whatever is for the most part carried by submarine cables. I think most people don't realize that that is the case. You have submarine cables crossing the oceans, terminating at very discrete buildings. Another building in the industrial area. Main Straits, North Sea, and the Atlantic. On this map, you can see sea cables which we're responsible for. The TAT-14 is the 14th transatlantic transmission system. The TAT-1 was installed in 1957. So the TAT-14 is a ring system connecting Denmark to...
Dry part meets the wet part. You can have somebody in Denmark entering something, a Google search. That request is coming here.
For that signal to travel to the US and back will be around 80 milliseconds.
I mean, this.
The cable system is being monitored by different management systems. Green is that you're all good, and if you get the changing colors, these are notifications of technicians working on network development. Fall between Sweden and Bornholm, where our cable took a hit from an anchor. One shows the damaged cable section. You have different layers of armoring, a stronger armoring in shallow waters, and then the deeper you go, you require less armoring when you're out in the... We have a cable caught on the cable from here to the US. I mean, there's no data. There's no connectivity. And if you consider the fact that all intercontinental data traffic is carried by days are filled with routine jobs, what? Target. And maybe that's also the reason why there's no big signs on the building.
And the power cable. As simple as that. 7,500 kilometers.
And now it's too much filter.
internet, all those network requests that you send, and if your API is in CBL, like, because it will take all of it. Questions? Yeah, like now, but there are more than that. Yes, there. It's kind of mind blowing. Cool. So. Realize that it is just computers connected and understanding how things work, distribute information more easily. I think the computer. Oh, also wait, before we do that, to the internet and net. The largest either a server or a client. That's correct, right? The client is, and remember that all these ideas come from the real world and more like predate the internet. As Alessandra said, like a client will be a and responses or services instead of the real world. In that, parking tickets, buying tickets. Like, say more about that. Who's the client and who's the server? The engine more. Yes, like what is the medium? I think we talked about the actors, right? speech. That's the meaning. When or the internet. So anything. That's correct. Cool. Communication. Anything that can consume our phone doesn't have to be. I don't know who it is. The ones that. So this is a network provider. The network is offering something that can be printing. Chuck, does this work for you? This 1.0, and then it's not like most of us is when another router, but it has moves to a 1 here. And there's more than 255 already like reserved for other computers. And also all share. When I'm making that replies back, when you type something in, and this is all happening .com. This computer, this Google computer is at. Try it with whoever is sitting next to you and to why you got and hit enter. IP address. Which one do you? Forehand. That's what it's saying. Or you want to ping are connected and number, and I send a copy. You see 21 GIF. There is an image seems to be here in one piece. This document over. Now again, that's like another layer. We'll skip some frames. It happens. So API to GitHub and any images you see on email server, Google servers. Oftentimes these servers are not like working in like we'll have a combination of processes the request. So you could create your own email server that will host Spectrum, which is my internet. No, I mean well your iPad, your iPhone.
Like all right, so
like what do you like? The IP address wouldn't do any difference, like what you want. So if you want, like basically, let's say we wanted to share files in this classroom. We could just have a computer that sits in this classroom always. Then we'll need to give that computer a static IP so that it never changes, so that anyone always in this classroom can access it and share information. Yeah. But like the internet provider, like static IP address, will be those are mainly given to businesses because they, you don't want that to change very often. Yes, Jonathan. Yes. All these computers are running 24/7. The servers, and if one goes down, there is some backup servers. I overheard that you guys were talking about backup servers, right? Or like computers. I remember I went to this building once. I think it was the Pursuit Net Contact, the Verizon building, NYC. Yeah, this one. We went to this building, and this building is Verizon has like a bunch of servers running in here, and inside there is an engine like that. It looks like a locomotive engine that will keep all this that will keep those servers running in case there is an outage. And then the last floor, like the basement, is the entire basement. I forgot how many liters of gas they have in the basement for powering the servers in case there is an energy outage, which was pretty mind blowing. It was a large number in cubic gas, or I don't know what you would call it, just fuel for this thing to run in case there is an energy outage. Yes, William?
Was that building just for the servers?
Yes, this is mainly for servers, yeah. Like I think every
Like they're all, they have to be housed in something like this.
companies are starting to build these buildings like in the poles so that they can benefit from the cool air from there, because you know this running all 24/7 quite intense. So yeah, that was that, and cool. Let's now talk about a client. So a client is any computer or program that can make a request to a server. So our computers here can be servers. Like at this precise moment, they are not servers because I cannot request information from Brianna's computer, for instance, because her computer is not a server. So far, our computers are all clients. They can request information from the local area network or from the internet, like google.com. Then inside there, as sort of another layer of abstraction, we can talk about two types of clients of my computer, right? So the browser is here, computer, to load regarding clients and servers in this context. So yeah, like at some like layer, we could say clients will be computers, right? But we could also say at a higher level, we can say more specifically, like the browser is the client. The browser is the one that is making the request, right? We saw that we've used them here. Client, like curl. Let's see if we do man curl. Yeah, curl is a tool to transfer data from or to a server using the supported protocols. I was expecting it to say client somewhere, but it doesn't say. But yeah, curl is another program that is a client that can request information. What's another one? The one that you were using with Pokemon API. Postman. That is. So these are that is sending the request. So these are again client applications. My computer as a whole is a client. Yes. Right, and when you play online games, when you're connecting, so those online games are all the stuff that is under the hood is the stuff that we're learning here, like network requests. When you're connecting to one of those servers, you call your computer a client, or you join. What you're basically doing is joining a server that hosts the game and all the data on it. Cool. So those were client applications. And we talked about IP addresses and DNS. Let's review. So the DNS is the domain name servers. Just think of it as the phone book. The HTTP, the hypertext transfer protocol. We saw this before too. So there's HTTP. And these are the HTTP protocol is the one that defines the rules, right? A protocol is just a set of rules. It says messages should have a header and a body. It says the stuff that will go in the header. It says that a message should have a URL, right, or an endpoint. Those are the rules sort of the game. And then when we make, we talked about this already. Like when we make a network request, what you get back are, well, fundamentally just information. But we could say, we could raise ourselves from that level of abstraction and think of it as component files. So when you make a network request, you're getting HTML, CSS, and JavaScript. those are files that are code, right? Those will be, if your client understands that code, that is, if you're retrieving those files with the browser, for instance, then those code files will be interpreted by the browser, right? The browser interprets the HTML, the CSS, and the JavaScript. If, for instance, I'm accessing that same URL with something like curl doesn't understand HTML, CSS, or JavaScript. It just understands the raw data. Curl will give me the raw HTML, the raw CSS, and will not do any interpretation. And another kind of files that get transmitted are called asset files, and these are mainly anything that's not code, basically, like images, music, video, documents, etc. So for instance, here we can see, if we go back to the network tab in here, you can see network. Let's refresh this. And here is, we can see all the network requests, and we can see basically the type of them. So this document, for instance, this will be HTML, so that will be code. This GIF or GIF will be an asset. This is the loading animation. There's some style sheet. There's some images here that we cannot see, but this will be also an asset. And anything that is basically not code will be one of these. Questions or comments about this? Yes, Jonathan.
Start making our own websites, right? Are we going to be able to make our own DNS names, or have to pay somebody?
That's a good question. So you will buy a domain name. You have to pay for it. I recently got mine. Mine is alejandrofran.co, and I put my website here. So basically, I bought this URL, or this name. I bought this name so that all the phone books register me as this name, and then this name in those phone books are pointing to an IP address that GitHub is giving me. GitHub lends me the IP address for free, but for me to get this, for me to get this name, I had to pay for it. I think it's like, I paid like $14 a year. Yeah, it's not bad. That's because it just goes with my name, Franco, and also it happens to be that I'm Colombian, and this is a Colombian extension. Yeah. I'm using GitHub Pages. So GitHub allows you to make like your some of you have been putting your projects on GitHub Pages, and then people can see them. You can just share the link, and they will actually see your HTML rendered. So I have the same thing. It's just that I connected that with this domain name. Mm-hmm. So you can get, yes, you'll pay for one of these. You can buy those at Google Domains or GoDaddy.com. Mm-hmm. Cool. Any other questions?
It's not just video games.
And then I'm like, my mom, you want to do this.
Okay, so let's build our own server. First, let's think about what the server needs to be able to do. So before we can build our own web server, we have to understand what the server needs to be able to do. What is it? How is it that we're going to set up our computer so that it's able to do this thing? So there is another schematic here. We saw, so we'll have the client on the right side and the server on the left side. Then the server, or the client, in this case the computer or the browser, will make an HTTP request to the server, and the server will respond with an HTTP response, right? Back with the information. So this server here, this bigger circle here, is sort of representing a computer that is set up as a web server, right? Then in there, like some components of that web server will be the HTTP server. And then here, I think instead of files, I'll name these like resources, basically. Because resources can be files, but it could also be just information like JSON. A resource could also be a service, like printing a document. So, right, so let's look at this. So a basic server needs to be able to do the following things. As Jonathan says, this computer has always, it needs to be running all the time. And it needs to be running on a certain IP address, right? Now that website has to, or this server rather, because it's not a website yet, needs to be able to recognize requests through a URL. So URL, sort of let's clear this a little bit. So URL stands for Uniform Resource Locator. Right? So URLs and IPs are closely related because, so we saw that, so what do you think this means? Like uniform resource locator, or at least this part here. Location is a keyword there, right? And the other keyword resource. Yeah.
That it's always the same, it's uniform.
That is uniform. This will, not that it's always the same, but that it has a certain structure, right? So that structure is as follows. So these are like sort of some of the TP normally are made up of 3 or 4 components. So the first component is something called the scheme. And for us here, this scheme identifies the protocol to be used to access the resource on the internet. The one that we're using the most is HTTP. So the scheme will be HTTP, right? Where should we do this? So HTTP / and then after that we have a host. The host name identifies the host that holds the resource. What is another word for host? A little bit louder? The container? Yes, that applies. Server. Right? You can think of the host also, like when you're hosting somebody in your house, you are the server. You're offering the service for somebody to stay in your house, right? You are the host. Right? So here we could say, the server. So the host name identifies the server that holds the resource. For example, www.example.com or google.com. So that will be in here. The host could be www.github.com. And a path. This is if we're accessing a specific resource within this server. So we'll have oftentimes you have after the host, which includes the domain name, right? Like this, we saw that this name, GitHub, will be looked up into the giant phone book called the DNS server, and we'll get an IP address. And then everything after here, we call the path. The path. So for instance, let's see if I remember Alessandra's username on GitHub, and her username is scripter12. Is that correct? So this is, I'm accessing at this location. That is why the URL stands for Uniform Resource Locator. At this location, I can find information about scripter12. Right? And then after that, we have the query string. That is if we are sending other information. We're going to get to see this more often as we move along the unit. But questions around the URL? Sergio? Sure. Right, and then so we went into that. So a server, as we say here, it has to have the ability to recognize requests through a URL, right? Then that server will process a request, do some work, right? Because the information for scripter12 might be on a different computer. So the server will have to go to that computer, retrieve the image, or all the other kinds of information like that. Like the repositories might be like, we can think of the GitHub computer as like one big thing, but in reality, GitHub has thousands of computers, and the resources are distributed, right? But we can think of it as just one big one for this purpose. But then oftentimes the server will need to do some work. It will see the incoming request, and it will do some work with whatever the content of the request is. So in this request sort of that we're making here, the only content that we have is just the URL, right? So you will need to do some work with that URL, handle some sort of logic and computation based on the URL. We saw that we can make different kinds of network requests, right? What are those kinds? Get, post, yeah, and the others, right? So this is, I meant to change this earlier, but I wanted to change this to something like the server will process the request and do some work based on the URL or the content of the request, because we saw that if we're sending a post request, that will actually have content and will have some body that we're sending, right, with some extra information. We want the server to be able to process that. And then the last thing that the server needs to be able to do is, once it has done that computation, once it has gathered the resources that a client requested, it needs to be able to send back a response to the client, okay, with all the information that gathered, or with whatever response, appropriate response to the request is. That could be, if you're making a request to iTunes, the response will be, the song, probably with the title and some extra information. If you're making a request to the Pokemon API, the response will be a Pokemon or Pokemon information. Other questions around here about what the server needs to do. So we have to configure our computers to be able to do these things. And it's actually not that complicated or not that hard to do. So, cool, let's write some code then. So we saw that, as we said, all our computers currently are clients. I cannot really access stuff that is in your computer because your computer is not a server. So let's learn how to turn our computers into a server using Node and a built-in module called HTTP. The HTTP module would allow us to make network requests if we want. So we could have used, I showed how to use Access with Node to get the Pokemon data, right? It turns out that there is a built-in module called HTTP that could allow us to make the same network request too. And then this module can be utilized to both make network requests to other servers as well as creating our own web server. So let's jump right into. I'm going to create a folder here, CD core unit 3. I'm going to create a folder here called Intro to Servers. And in this folder, I'm going to create a file called server.js. It doesn't have to be called server.js. You can call it anything you want. I created a file. I'm going to open my folder, my current folder with code. And we have an empty JavaScript file, our canvas. Let me change this. Then I made a folder called Intro to Servers. Everyone has their empty file. So the first thing that we need to do is import. Let me disable this thing. Oh, reload. So the first thing that we want to do is, how do we import modules if they're built into Node? I mean, with require, right? Require. Why is it auto-complete into that? Let's declare the variable first. When I say that into something called HTTP, I'm gonna do require, and then HTTP is the built-in module. So I don't have to install this with npm because Node already comes with it. So we do HTTP. Then the next thing that I want to do is I want to create a variable called port. We're going to talk a little bit more about this next. And here I'm going to specify a port. I'm going to pick port 3000. This has to be a number. So here we're importing the module. Here we're just declaring a variable, this variable that is holding a number. And then the next thing that we want to do is create a variable called server that is going to be equal to calling HTTP that. So the HTTP here, the HTTP module is a what? If I'm doing dot notation, what does that indicate? Right. So there is a method called create server that I can call like that. So let's look at the documentation. Go to node.js.org. Oh. And here, so all the documentation for the built-in modules will be in this website. So I'm gonna go to here. I'm gonna search for the HTTP module. And here we have all this. Let's search for create server, and let's read a little bit about this. So the HTTP create server seems that I can pass in some arguments, something called options and request listener. Let's see what else does it have. So it has some history. Actually, it doesn't say much about like the server itself. But we can just know by the name that this will create a server object. This is the one we're going to use. So let me look back here. So we create the server like that. Now, creating the server is not enough. We need to have this server run all the time and listen for upcoming requests. So we will do that if we do server.listen, the server object. And here we need to specify, we must specify the port at which we want to listen. So here I want to specify the port is just what I have in the variable port. And then here we have to specify a callback. This callback will get executed when the server starts listening. So then I'm going to do console.log. Actually, wait, give me one sec. So I think this callback here, listener. Yeah, so let's just do console.log server running at HTTP / localhost. Actually, and then I want to do string interpolation here so that we specify the port. This server will be running at localhost : port. So this is how we can create our first web server. Now, how would we run this web server? Peter? Yeah, sure. Yeah, so it turns out, I guess let's talk about ports now. So you see, you can think of these ports as, since again, this is all like coming from real world example predating the internet. Hugo, do you have a question or comment?
When I used to game, we could make like private servers and usually you had to go into the internet router and open up the ports so you could get to.
Yes, that's one example. But these ports, you can think of it as, so localhost, this will be like our local address. But this port, so this is like the domain name, right? This is just one that we all have. Like we all have like localhost. It just is a reference to the current computer that you have, right? And the port, you could think of ports as like ports in real life. Like you could think of, America, the United States. How many ports does the United States have? Ports of entry. How many? It has 328 ports of entry. So there's 328 ways in which you can get into the United States. That is probably airports, right? What do you call the ones for ships? Piers? Just port? Okay. What other ports do we have, like from airports and regular? I guess, the borders, yeah. Right? So this is where this idea comes from. Like, to access the United States, you could access the United States through one of these ports, right? Similarly, to access our computer, so our computer also has ports. There's a large number that I was just looking up. 65,535 ports. So there is this many ports that I could access. I could have access to my computer. There are some ports that are standard to be used for one particular reason. Let's do standard. I know port 80 is for HTTP servers. Ports. So these are like standards. Port 80, so FTP. So if you're building an FTP server, you will put that to listen on port 20. There's 21, 22. 80 is the one that is most used for the HTTP protocol. We could use, let's try it first with 30,000 and then we can try to change it to 80. But yeah, your computer has ports, and then some port numbers are used for some assignments or activities, kind of activities. I'm not sure if you could change them, if you could have like port 20 to be used for hypertext transfer protocol. I believe so, but I have never done it. But yeah, from these ports, you have how many? 65,000. You'll probably not run out of ports. And these are the main ones. Let me share this with you too. So these are 65,000 ways. Then you can see here, as we were looking at here, that the host section, which is this part, this host, can also, it says, host names can also be followed by a port number, then refer to port numbers. Well-known port numbers for a service are normally omitted from the URL. We can get to see this. Most servers use well-known port numbers for HTTP and HTTPS. So most HTTP URLs omit the port number. That's why, since 80 is the standard port, that's why you don't have to say github.com :80. It's just because this is the standard for HTTP, right? So you will do, but for us, so since we're just starting, we're gonna use our domain name called localhost :3000. In this case, we have 3,000. So note that yes, the URL or the host section, which is this part, between the second slash from the protocol to the first slash of the path, that is all the host, and you can have a port number. So here, to Peter's question, we use 3,000 mostly for development purposes to try it out, because we know that no other service will be running on that port. Mm-hmm. You can pick another one, and if you take one of the predefined ones, then you might get an error, or your server might not work. Yeah, but otherwise, yes, that's why we pick like 3,000 here. Actually, like some people like 3,100, but you can put in here anything you want, any number between the range of 1 to 65,000, whatever number. Okay, so let's run this. We can do that if we just go to the terminal. I have to go on my folder. Cool. So everyone has the terminal, and then you can just do the way that you run any JavaScript file, node server.js. And we have our first server running. Congratulations. So, was everyone able to see this console, server running at? Mm-hmm. Now, actually, I'm gonna cut my server. I'm gonna cut it with Control-C to exit. So you can see that this is like, it seems to like be stuck, but it's not really stuck. It's listening. Like this server is listening for upcoming requests. It's waiting for requests to come in. I'm not sending any requests yet. But before we do that, I want to see. I'm gonna cut it. I'm gonna first copy this URL. I'm gonna kill my server, and then I'm gonna go to the browser and paste this URL here. So I'm gonna hit enter. And I get this site cannot be reached. Let me see. Ping. I want to do ping localhost. No, this doesn't work here. Anyway, so but this localhost will resolve to your IP address. So, like in my case, this localhost will resolve to ifconfig 192.168 0 0255. So like here I could type that 168.0.255. And it says that this site cannot be reached, right? Now let's take a look at what will happen if I run my server. So I'm gonna do node server. So now my server is running. I'm gonna refresh this page, and note now that it's loading. So I don't know if you can see this in here. It's not very exciting, but it's loading. What happens if I cut my server midway? We cannot really see it load here because I have too many. Oh, there we go. It's loading here. I'm gonna kill this, and it stops loading. So that means that my server, or the browser was able to reach my server. Well, what did we say the server needed to be able to do once it received a request? Send back a response. My server currently is not doing that. Is listening, but is not doing that. So here I can do. So this will be like your IP address. But for us to not have to remember this, we could just use the name localhost. Localhost. Note that if I do the same, I have my server running. Refresh this page. The browser here is waiting for the server to send back a response, but my server is never doing that. Yeah. So what did we do? Let's look back at our code. We declared a port. A server is just a computer program running on a computer. The entire computer has an IP address, right? So this was the analogy with my computer and America that has many different ways of entry. So I have, my IP is like the name, right? Is America, and there is I want to specify what port do I want to come in through. What makes the port so special is that you're indicating that this specific computer program and its functionalities can be accessed through this specific port. So that's like this variable that we did here. And then we declare the server by creating a server with http.createServer, and then we did server.listen. We ask the server to start listening on this port, in this specific port. Then this is also said to be attaching our server instance to the port, and we basically now have a live server running all the time. So, questions about the code here, or comments or worries?
Would you ever want to randomize the port number?
That would be interesting. I don't think you will want to do it because then you have to also guess to what port to connect. The question was like, would you want to randomize this number? That wouldn't let you have like reliable resource access if you're building an API and the port is always changing, right? Other questions or comments? Hubble? Yes, so I could serve different information in different ports. Yes, like as we saw here, the Wikipedia post. Yes, these ports are utilized for different kinds of information and communication. Yeah. I could have. So my computer, I could turn my computer into a server. I'm doing that now here, and only one server. I could have. Oh, this is important. A server can only listen on one port. So if you want to listen for something else on another port, you will need another server for that. The thing is like, well, my computer has the potential of creating. If I want to listen for all these ports, I'll need to create 65,535 servers. But we rarely go there. Well, actually, I've never gone there, and I don't think you're ever going to go there. A server will always, it must listen on a specific port. Okay, so let's have this server do something a little bit more interesting. Let's have it actually send a response. So for doing that, let's do, let's try to access it with curl. Curl HTTP / localhost and then 3000. Oh, so this is what happens if I try to connect with curl. I try curl and then this, my local name 3000, the port, and then it says failed to connect to localhost port 3000, connection refused. Why is it that? It's not running, right? That's a very important point. So let's have it running. And I have it running in here. ls node server. So now it's running. Now I'm going to repeat my curl request. And now curl is just sort of waiting for a response. See here? Curl is, it just hang because, you know, it's expecting this client, curl is expecting a response and is not getting any. So let's actually send something back. I'm going to cancel this with Control-C, and let's actually send something back in here. I'm going to kill my server, Control-C, and now, so for responding to requests, what we need to do is we need to pass in a callback function here to the create server function. So let's look at this in here. Yeah. So okay, I'm gonna do. So here in the lecture notes we're passing in this callback function, right? We're defining this callback function in the argument, right? And this is fine. But I wanna be a little bit more explicit and say something like const. I'm gonna create a function called request handler equal a function. Now this function is gonna pass here to my create server function invocation request handler. So this function, just like what does this sound like? Like there was another instance in the past unit where we had something similar to what we're doing here, passing in callbacks. Tuple? A little bit louder?
Yes, the fetch request.
The fetch request, so you pass in callbacks. And why is it that you pass callbacks to a fetch request? Or, yeah, like fetch. You pass in a callback to be invoked whenever the request succeeds or fails, right? Or also, the other instance is when you add an event listener to a button, right? The first argument is the name of the event you want to listen for, right? Like click. And the second argument is a callback function. That function will be called whenever the event happens, right? Here is the same thing. The request handler is a function that will be called whenever the server, which is listening, sees a request coming in. So whenever the server sees a request coming in, it's going to invoke the request handler. Now this function here receives the request object as well as a response object. Response. Right, so in this function now, what if we do, so these are two objects, the request object and the response object. So these are representations of the request and a representation of the response. So what if we try to do console log request to see what is inside? And let's just leave it like that. So I have a request handler. The arguments that it receives will be the request and the response, and I'm going to console logging the response, or actually the request. And then I'm passing this request handler to my create server function. Right? Now run your server, node server, and then make a request with either with the browser or with curl. And tell me what you see. Do you see a console log popping up? Oh, you got something called incoming message and a giant object, massive object. Who saw that? Raise your hand if you saw that. Okay. Where is everybody else? Do you see? Is your code like this? Everybody else who hasn't seen the massive response or the request, the incoming message. So let's look at it here. So I'm going to create this request with curl. Just repeat the request that I did earlier. Curl localhost colon 3000. Also, since this is going to be massive, I'm going to raise this here. And then I hit enter. Curl still just hangs because curl is waiting for a response, and the server hasn't given that. But in here, we got this massive console log. I don't even, yeah, okay, so I got to the top. It says incoming message, and we can tell that it's a giant object. It has many, many keys. But this object represents the request that I just made. How so? If we hunt somewhere here, we should see something that makes sense, hopefully. Let's see, destroy, writable object, server. Here, for instance, you see the server. So it seems that the request has something called a server inside. We see the 3000 here. We see the port that we set. This is all other information. Let's see. Here, this request object has a property called headers. You see this? You might have trouble finding these things. I had to scroll quite a bit. I think if you're in Visual Studio Code or even in your terminal, you can do Command F and just search for headers. And here I should be able to see it. So here I found them here. So we see the host is what we name as our host, localhost. We also see user agent. User agent, it says curl 7.54. This user agent is who made the curl quitted. Says empty reply from server. That's cool. Curl will give up if he doesn't get a response fast enough. But the user agent in here is curl. It's telling this request was made with curl. If you made this request with Postman or with Chrome, you will see a different value here as the user agent. This makes sense so far here. This console log inside of the request handler function. So this function, the request handler, again, is going to be called on when the server listens for a request. When the server sees an incoming request. And then we were able to see that. Let's do maybe, so since this giant object is kind of hard to parse, let's look at just request.url. Maybe also let's do request. So since we saw, inspecting this giant object, we saw that there is a request.url property. Let's look at also the request.method property. So instead of console logging the entire request object, which is just huge, I'm going to console log request method and request URL. So I want to, any times you'll fall in this trap, even if I tell you now, but every time you make a change to the server, like changing the code of the server, you need to kill the server and start it again. You need to kill the server and start it again. Sometimes you will make the change and you will say, why is it not working? And it's because you forgot to kill the server and restart it. So I start the server again. Now I'm going to do curl, repeat my request, and then I see that I got a get request to this endpoint, to just the slash. Now I'm going to kill curl because curl is just waiting. Now let's do, actually, was everyone able to see this? It's important that you get to see it on your own. One more time, the request handler is being called on every incoming message. That's why I named it the request handler, because it's supposed to handle the request. So far, it's just console logging the request method and the request URL. So now let's do, what if I do localhost colon 3000 / hello. Yeah. I'm gonna hit enter. Now I see that I got a get request to / hello. What if I do hello 6.2 fellows? Making this request to http localhost 3000 / hello / 6-2 / fellows. Then we got that this is the URL to which the request was made. What kind of request I'm making with curl? Making get requests. Kill curl, and that's it. The client-server transactions happen. So, was everyone able to see this going on? It seems that there is another request coming in. No worries.
Give me my food. I'm so sorry.
You know, the server gets confused sometimes. Wait one second. FTP, file transfer. No, that would be more like a, I see, a food transfer protocol. Yeah, that would be good. Douglas, you had a question?
I'm just having trouble getting any of this to do any.
Did you restart the server? Oh, somebody did this. Somebody, send an error request to my IP. You can send an error request from your computer to my IP, to this IP, do / something, and then it will pop up here. Somebody got it. That was you? Cool. So try that. Put this, instead of localhost, put my IP address, :3000 / your name. So instead of curl, I'm going to do it first. So HTTP / 192.168, my IP address 255 / Alejo. Oh, wait. I forgot the port. There, I got. So now my computer is a true server. Is, well, at least, well, it's halfway there. Is receiving incoming messages, and you can see them. You can see them as they're coming in. Cool. Yes. My console log. Console log is console log request dot method, comma, request dot URL. No. Look at somebody else's code, and you must have something different. Oh, let's visit this person. Wait, who's? This is yours? Okay, I see. I'm not gonna do that then. Yeah.
I'm not getting anything. So I've got, I keep on getting failure to try
Oh, okay, go little down.
So in this
So yeah, you need to have their server. what are you trying to do? Okay, so for doing that, then you don't need to have your server running. You're actually going to connect as a client to my computer that is acting as a server. For doing that, you're going to curl. Yeah, that's correct. And it doesn't really. Yeah. Yeah, for some reason you cannot see it. But it's not your computer.
Yeah. Like you should have get everything else type in. Once you have get underneath there, you'll be able to get whatever quality next. Let me get right there. It's right there.
See, like, my computer can see
Not there.
this.
Oh my God. Fight you.
Yeah, I'm not sure actually. But I think it doesn't have to do with your computer. It has to do with the network configuration that we have here. Yeah, you might not be able to make the request here to my computer because for some reason that I'm not sure why, your computer cannot see mine, even though we're on the same network. So you might be just see sort of curl just hanging in there. Oh, is that a question? This is going. Okay, let's just kill the server. Cool. So the last thing that we want to do is actually then just send that response. So let's actually send that response now. So we saw that we were able to console log the request method. So if I have if I run my server, we saw that if I go to the browser and I try to access this URL, my browser just hangs loading there for a little bit, right? That is because my server currently is not sending a response. So we will want to send a response. For doing that, that's why we have the second object here called the response. So we can say something like response.end. And here I'm going to pass in the word, this is a response from my server. This is a response from my server. So the end function in the response object will actually send the response. So let's look at it. If I run my server, node server, then on another terminal, I'm going to do curl slash Alejo, and then we get now a response back. Yay. So now curl didn't hang there, right? So if I repeat the request now with curl, because now we're saying response.end, this is a response from my server. Now we actually got that as our text. Do these changes and make sure you see them on your own. You might be getting an error. You might be getting this error. If I open up a new tab in here, so my server is running. My server is running already here. If I try that in here again, node server.js, then I get this error saying that address is already in use. Right? You cannot run two servers on the same port. That's what it's saying. So you may be getting this error. Just make sure that you find all your terminals and kill all your servers. Kill the server that you started before. So here, now we see curl is able to get a response back. Now, let's try now this with the browser. Go to the browser, localhost 3000, hit enter. This is the response from the server. Yes, you will. Cool. Everyone was able to see the response, to get a response, right? Let's see what kind of response we got, because we didn't specify a lot of information. We just said response.end and then this text. Let's refresh. Seems like by default it's sending a 200 OK. If we see a preview, that is that. Response is that. It is also doing a lot of other stuff, like this is all the server is doing this automatically for you, which is setting the status code to 200. We could set a different status code. It is also setting these headers, like accept. No, these are the request headers. The response headers are content keep alive 3. This 33 is, there's 33 characters here. If we go to the network here, this content length, there's 33 characters, including spaces in here. And then the date, right? So, questions or comments on having the server now not only listening and replying to requests, not only listening but also replying to requests. Yes. A little bit louder. Yes. Mm-hmm. Yeah. So that's a good point. Like Node has the event loop the same as the browser. So that is how this server is able to listen, because it's an infinite loop that is running, always checking for upcoming requests, basically. Yeah. So let's see the last piece.
I have a question.
Yes. Owen. Yes, you could, like in here I'm just sending like plain text, but I could send anything. I could send a JS file, a photo, anything. Yeah. That requires a little bit more stuff, but it is possible. I want to see, I think I'm missing. So here, like the example that we have here is, oh, I should also see this. Yeah. Okay. The example that we have here is a little bit more well constructed, which is setting the status code explicitly. So let's do that. Let's do response dot status code 200 status. Setting the status code to 200. We saw that it was already by default is 200. If you want, try a different one here, like a 418 is the teapot. Now repeat the request in the browser by having, while you have the network tab open. Network, refresh. Oh, I forgot to kill the server. Now we got a 418 on the T-bot. So you can control the status code of the response by saying response.status code and then whatever status code you want. The 418 is the teapot. 404 not found. And okay, so let's do that. And then instead of replying with just a string, let's reply with some JSON data. So what I'm going to do here is maybe const. Let's do user. Let's imagine we have a user, and then that user has a name. Charles. We don't have any Charles in the class, do we? Last name. Let's do Doe. Maybe phone. Or maybe just age. Age 26. Now we have this user object, right? And we want to send it as the response to a request. But now then we have to think about, oh, so this is an object in JavaScript, right? We need to convert this object to a string because that is the format in which all the data that we're sending and receiving from web servers are transmitted in just plain strings. So for doing that, let's just do, I'm going to call const, I'm going to create a variable called data. And what I'm going to do to convert this, and I want to convert this user to a string, but not any kind of string. I want to convert it to a JSON string so that it is in JSON format. So for doing that, we can do JSON.stringify and then pass in the user that you want. I call this like JSON data there. JSON data instead of just data. So, and instead of sending this string, now what I want to send is the JSON data. I'm going to change the status code back to 200. But I'm just going to say response.end JSON data so that I send that data as the response. Let's refresh. Oh, I have to run the server first. Refresh this here, and now I got my JSON. It's just that it's so big. Now I got that user as a JSON string. Then you can make an API.
Yay!
Yep. It's pretty cool. This is how I made the to-dos API for the class and all the others that have done. You just have different ones. And also here, well, also any questions before we go? Janesh, the console, like here. Right and hit enter. Oh yeah, this is the extension. Yeah. Other questions? The one thing that I should do here that I think I'm not doing is, if I go here back to my network, all this stuff is because of the extension that I have for like beautifying this JSON. But in here, I should have, since this data that is coming in is this JSON string, this is what it looks like raw. I should specify, it is good practice, and we're not gonna have to do this manually a lot, but my request, I should set the response headers to say that the data that is traveling is JSON data. Right now, this is being done automatically, but I want to set a header here that will indicate to the client that what he got back was JSON data. To do that last piece, we do, can be later on here, response dot set header, I think. Let me just check here because set header, yeah. Set header parentheses, and then the header that I want to send is content type. I'm not sure if I need the content type and then the kind of data that I'm sending back, which is application/JSON. So this will set a header in the response so that whoever receives the response, this is because, well, the browser is smart. And if it sees JSON, it will try to convert that. Oftentimes, the first check that the browser will do to convert something to JSON is to check the headers and see if it says application JSON. Let's try this one more time, and then we should see here. We should see now that in the response headers, we have a new header set. Localhost, response headers, now we have the one that we set. Application, content type, application/JSON. That's basically all. So have lunch after lunch. Please reconvene here. We're just gonna see how to like build a simple website around it, and then take the exit ticket. But let's do that after lunch.